All right, so I'm looking at um, 3C. So let's say your true height is 73 inches. That would be 6 feet and 1 inch. Which are measured at your doctor's office. At 72.5 inches. Right. Or 6.5 feet. Right. And we want to find the absolute and relative errors in the following situation. So first, absolute error. Now your absolute error is simply going to be your measured value minus your true value. So that's going to be 73 minus, or excuse me, that's your measured. Absolute error would be your measured value. 72.5 was your measured value minus your true height, which is 73 inches. So that's going to be negative 0.5. So that's the measure, or your absolute error. Now your relative error is a comparison of the size of the error to the true value. So that's going to be your absolute error, which was negative 0.5, divided by your true value, which you're comparing it to, which was 73. All right, and that comes out to be negative 0.007. So, or you can say negative 0.7%. So I just turned it to percentage there, just moving the decimal place twice. And that's it. So you were asked two things for your absolute error, which we got here, and your relative error, which is right there. Okay.
Okay.
All right. You said the other one was number 20?
Yeah.
That's problem. Okay. This is probably the toughest problem that out of the assigned problems.
Yeah, I definitely had trouble figuring that one out.
Okay, and the second one, second part of it, I think is even a little bit more difficult because it's dealing
Yeah.
in terms of percentages. All right,
Mhm.
so let's work through it. All right. So let's suppose, in this case, this is number 20. We want to cut 20 identical boards. Cut 20. We want them to be identical. And we want the length of these boards to be 8 feet. Okay. So what we're going to do is we're going to cut the first board, measure it out, 8 feet. And once I cut that first board, I'm going to use it to measure, mark off, cut my second board, and then use the second board to measure and cut my third board, and so on and so forth, till I get my 20 boards. So question part A is going to say, what are the possible lengths of the 20th board if each time cut board there is a max error of and plus or minus 1/4 of an inch. So you could either be a 1/4 of an inch too long or a 1/4 of an inch too short on your cut. So now, but basically what we're gonna have to do is assume, okay, it's possible that I could be a 1/4 of an inch too long. Each time I cut a board, measure and cut, which means the errors are going to accumulate as I go. And then the same thing, I can be a 1/4 of an inch too short. So I'm going to have to actually calculate for both.
Okay.
Both too long of a cut and too short of a cut, right? Okay. So we'll go with I come up short each time, a 1/4 of an inch too short. All right, so now since this is in inches, and I'm talking about, and when I put one tick mark up there like this, prime mark, that means feet. So this is 8 feet. So I want to be making sure I'm talking in the same units.
Okay.
Therefore, let's take that 8 foot and we're going to convert it to inches. And I think the answer is actually asked for in inches anyway.
Okay.
So that would be just be times 12. That is 12 inches is 1 foot. Let's cancel out there. So 8 times 12 is 96. So I've now got inches. All right. So each time I cut, I'm just going to assume I'm at that max 1/4 of an inch too short. The first board would be 96 minus 1/4 of an inch. So what I'm going to do is just kind of, so this is actually when I measured myself. The first board would be 96 minus 1/4. And for right now, I'll go ahead and put 96 inches minus 1/4. Now, I mean, we could go do the arithmetic there, but we don't need to. What I'm going to look for is a pattern here. Second board. Well, I've already got the 1/4 inch from the first measure, and now I'm going to have another what? 1/4. The third board, this is the last one I'll actually write out, would be that starting point 96 of an inches, 96 inches, minus 1/4 of an inch, minus 1/4 of an inch, minus what?
1/4 of an inch.
Inch until, so I keep doing this till I get 20 boards. So it would be easier just to go 96 minus what? 20 times 1/4. And now 4 goes into 20. Luckily enough, we could just do this mentally. 4 goes into 25 times. So this is just 96 inches minus 5 inches, which is 91 inches. So that 20th board could be, if you had a max error of -1/4 of an inch, that final board could be as much as 5 inches off. That is, it could be as short as 91 inches. All right. So if we use the same exact process,
Mhm.
then without having to write all this again, but adding 1/4, then this board would be 96 inches plus 20 times positive 1/4 of a inch. So that would be 96 plus 5 inches, which would be 101 inches.
Mhm.
So the 20th board could be, again, on this is with the max error, assume anywhere from 91 inches to 101. And that answers part A.
Okay.
Right?
So it doesn't matter which one that you do, like you subtract or,
You have
Okay.
to figure out both.
okay.
I only wrote this out just to kind of get an idea of why I was saying times 20. But
Oh,
once-
okay.
yeah, that was just to get the pattern down.
Okay.
So one case you're going to be minus 20 times
Mhm.
worth, and the other case on the if the cut was longer, then plus
Then
20
you're gonna-
and so forth.
Okay.
And that
that
gives
makes
you your
sense.
range.
Okay.
Okay, now, and that to me is now honestly the easier of the two. B is a little bit harder. So, but we'll get it. But that answers part A. All right. So I'm going to turn the page if I can.
Mm.
Go to part B. Now, we're going to ask the same question again. What are possible lengths of the last board, 20th board? If each time you cut a board, there is a maximum error of plus or minus 0.8%. So remember this, when we're dealing with percentages, we're comparing. So you would take the length you wanted that board to be, and what you're saying is you want it to be 8 feet. So you could have it be as short as 0.8%, or you would want to multiply your length, your desired length of 8 feet by 0.008. That is turning it back to a decimal number. And then that would be your 0.8% of the length of 8 feet, and take that away from 8 feet, and then that would tell you how much you came up short. So now, so if the first board, and again 8 feet, remember that is, we figured up to be 96 inches. So if you've got an error of negative 0.8%, so I'm looking at the shorter side right now, is made in that process, the board would be shorter than that, and it can be expressed as the target length by just simply subtracting 0.8% from 100%. So 96 inches is 100%
Mhm.
total board. So if I went 100% minus 0.8%, that gives me 99.2%. So in this case, when I said, and that's just kind of how I usually think it through, but if I first went 0.008 times the 96 inches, got that value and took it away from 96, I'd arrive at the same place if I take 96 inches times 0.992. And that would be exactly the length of that first board.
Okay.
And we don't really, and you'll see why in a second, need to actually do the calculation right yet. I'm going to go ahead and do it. This will be times 96. So it would be, your second board would be 95 inches, 95.2 inches rounding. Which is, and again, that would be as short as it could be. But remember, it's possible to have this 0.8%, be it short, 0.8% each time I cut it.
Okay.
So now, if I were, and I'm going to do the same thing I kind of did on part A. So we said we wanted to go 96 times 0.992, and that gave me the length, which again I figured up to be 95.2. That was rough, rounding to tenths place, but and that would be your first board, the length of your first board. The length of the second board would be 96 times 0.992 times 0.992. Whatever this length is, then you would multiply that by 0.992, and that would give me the length of the second board. And the third board, take the length of your second board, which is 96 times 0.992 times 0.992. So that's the length of the second board. So it's now going to be off. So this would keep up until I did this 20 times. So where it was a multiple in the first problem because I was multiplying, here, this is going to be exponent or repeated subtraction. So I times it by 20. This is repeated multiplication, so it's exponentiation. That is to a power. So the length of your 20th board when you get there, since you're going to multiply this out 20 times, the 20th board will be 96 and then times the 0.992 20 times. So, and all along this was inches. I didn't put the units in there. So if you get your calculator out and go 96 times 0.992 to the power of 20, you should get 81.75 inches. And so that's as short as this board could be if we have the error in terms of a percentage of the board. So if I want to figure up, so that is as short as it can be. To figure up as long as it could be, it would be the same pattern, except you wouldn't go with the 99.2%. It would be plus 0.8%. And that's going to give me 1.008. So, or 100 plus 0.8. well, there, hold on a second, that was it. Technically, I didn't have it as percentage here, so writing it as a percentage would be 100.8, which then converting to decimal form percentage would be 1.008. Now that looks better. So your calculation for as long as it could be would be 96 times 1.008, and then again you're going to be multiplying that 20 times. And that will give you the as long as it could be with this air, which would be 112.59 inches. And it does ask for you to round to hundredths place. And that is it. Okay, is that better?
That was hard.
It's a harder problem, especially with the percentages, but
Yeah.
so the big thing to remember is this calculation right here,
Okay.
right there, and right here.
Okay.
So, so what you're going to do when you rework the problem, you'll be given a different number of boards
Mm-hmm.
that you want to cut, and the max error will be different.
Okay.
All right. So what you're going to do to start is on one to find the shortest and then find the longest. For the shortest, take away this and leave it as a percentage. So you're going 100% minus
Okay.
this. Then take this, move it 2 places to get it in decimal form.
Okay.
Then it'll be, and of course you also have to take, it's going to give you that board in feet, convert it to inches. So multiply that by 12. That's where you're going to, so if it was 9 feet, you'd be using 108 inches
Okay.
right here. So see how this number goes right here?
Mm-hmm.
And the power will be the number of boards you want.
Okay.
All right. And then for the max, 100 plus whatever that max error is, and convert it to this. And again,
Okay.
so then this and this will be the same as this and this.
Okay.
All right.
It makes sense whenever you break it down.
All right. So, and then I also will post the video up. So,
Okay. Thank you.
okay. Any other questions? Reese?
Yeah, my only question I have is for the assignments and everything.
Uh-huh.
So the 3A video, 3B and 3C and 3D, is that going to be due here as well? Or is it just the homework
So
for right now?
3D, yeah, all I did was put the videos up for you to preview. I'm going to cover 3D tonight.
Okay.
And the homework I'm going to assign for Wednesday.
Okay.
Just for 3D. And that's the only assignment, new assignment. I'm not going to assign anything out of 120E tonight. I will have something on Thursday for that, but tonight will just be 3D.
Okay.
And just also, this is, won't be doing it tonight. I will be doing it this weekend at some point. Midterm grades are due Monday at 8 a.m.
Mhm.
So we won't have a midterm test. We're still a few weeks away from our second exam. So I don't have a midterm exam per se. It's just going to be a snapshot of where we're at currently as far as your midterm grade. A midterm grade has no bearing on GPA or your final grade. It's just a snapshot of where we are right now. But one thing I have not done up to this point is manage incompletes. And what that, basically I can go in and any assignment that is past due assignments are, if you have not opened up that assignment, they're actually not calculated into your grade. So when I just say, okay, manage incompletes for everything that we have done up to this point, it will go in and put zeros in for any assignment that you haven't started that is past due. You can still go in and work the assignments, but it's going to give you an accurate, because then it's going to calculate and you're going to watch your overall percentage drop, because you now have a zero in there. But again, you can always work past due dates. But I'll do that prior to, so wherever we are at the end of this week. So whatever I sign on Thursday won't be, they're not going to be due. So, but anything prior. So I would say probably midterm is going to go through 3D as far as assignments. We will cover next class 4A. We'll move into chapter 4, and that assignment won't be due by the time I do midterm. So that's more just kind of an FYI for you guys.
Okay.
All right, so moving on. New stuff, not new stuff. We have been beating percentages to death, and we're still going to beat them to death a little bit more. But some things that you have, I know, in your lifetime, have heard on the news, have read in a paper, newspaper, things like inflation. I mean, I know everybody's heard that term, right? Rate of inflation. And and it's how much overall prices of goods and services has increased over a period of time. And sometimes it does happen that overall that things decrease, and that's called deflation. At the end of the day, we're going to find out it's just a percentage. So that's what we're going to be looking at tonight. And so we're going to start identifying something we're going to call 3D index number. All right. So does a good little example here before I write a definition. The book has a good example. So let's say we wanted to compare prices from price for a gallon of gasoline. There's something that we purchase all the time. So if in 1975, it is 57 cents a gallon. And in 1985, it's $1.20. And those are very accurate numbers. When I first started driving was early 80s, and I could get gas in 1982 for less than $1 a gallon. Time I graduated high school, it crept up to a little bit over $1 a gallon. So, but if I wanted to say, well, what percentage is the 1975 price to the 85 price, then quick little calculation. We'll just take our 57 cents a gallon and divide it by our $1.20 a gallon. Now that's going to give me 0.475, or that as a percentage is 47.5%. So we can say, just on that calculation, that the 1975 price was 47.5% of the 1985 price. Now, I could flip that. I could do it the other way too. I think the book actually does that. Does it right here, but we could do that. But let's continue on another track. So I'm going to make a little table. I'm going to take the time to construct it. Let's say I wanted to put a whole bunch of these kind of calculations now, and I'm going to actually base them all off 1985. That is, I'm going to do 1965, 1975, 1985, 1995, 2005. I'm going in 10-year intervals. And 2015. Now then down the second column, I'm going to put what the price was per gallon each year. So in 1965, it was 31 cents a gallon. 75, as we already know, it was 57 cents a gallon. 1985, we already know it was $1.20. 1995, or not, it was $1.21. Jumped up in 2005 to $2.31, and in 2015, $2.52. All right. Now, I have a third column. I'm going to go price as a percentage of 1985 price. So we already did this for 75. We figured out the 75 price per gallon was 47.5%. So if I wanted to figure up the values for all the others, in this case, I would be 0.31 divided by $1.20, and so on and so forth. So if you go 0.31 divided by 1.20, turn it to a percentage, you're going to get 25.8%. Now, this one, 85, because I'm basing all of these out of what 1985's price. So this has got to be 100%. It's right on the nose. Where $1.20 divided by $1.20 is 1, and convert that to a percentage, it's 100%. This one would be 100.8%. This is because you would figure this would have to be bigger than 100% since this is more than $1.20. And this is 210%. Now, when we talk about index numbers, typically we write them without the percentage sign. I'm not going to move the decimal point and convert it to a number, a decimal number. I'm just going to say price index. When we talk about that index number, I just kind of ignore the percentage sign. So this would be 25.8. This would be 47.5. This is 100. This is 100.8. This is 192.5, and this is 210. Now, on the price index, you'll see this. Whenever you're looking at index numbers, I'm going to write 1985 equals 100. And when you see that, what it tells you is uh, what price did you base all of your index numbers. There's no, when you look at a chart like this, there's no magic as to why one year was picked over another. It's just, so that is, I could construct a whole nother table here and base them all off 1975's price, which was 57 cents. And I would be dividing all of these by 57%. I would get different index numbers. But they would all be based off 1975's price. But what we can find out is, what we're going to find out is there's value in using these index numbers to do comparisons. And we're going to see some examples of that in a second, once I have an index table built. All right. So definition of an index number. These are my index numbers here. So basically the percentages, and I just dropped the percentage symbol. But all of them are compared off one of the years, or one of the things I have in the table. So officially, the definition is an index number provides a simple way to compare measurements made at different times or in different places. The value of one particular time or place, in this case, we're doing times, is chosen as the reference value. In this table, we chose 1985 as the reference value. So the index number for any other time, how do we calculate it? We did what? We took our value and divided it by our reference value. And this just means turn it to a percentage. So I got to 25.8 by going 0.31 divided by $1.20. That gave me 25.8. So on and so forth. So let's say I wanted to compare. Now, as I said, once I build the table, and I have these out, I can compare other years using these price indexes without, where neither one of them are the reference, which in this case was 85. So say I wanted to compare how much more expensive was gas in 95 as compared to 1965. So attempt to write this in here so I can keep this table. So how how much more expensive was gas in 95 than in 1965. So I'll find the index number for 65. So that was what, 25.8. The index number, whoops. Wanted to do, I got that reversed, I apologize. The index number for 95, because I want to know how much more expensive it was in 95 than 65. And I don't know why I put this percentage sign there. It's supposed to be a question mark. So 95 was 100.8. It's right here. 65 was 25.8. Now, if I just then get my calculator and divide these two, you're in rounding the hundreds place, 3.91. So what we can say right there, right off the bat, is that gas was what, 3.91 times more expensive in 95 than it was in 65. Or is 391% of so as an example, since gas cost amount of gas that cost $1 in 1965 would cost you $3.91 in 1995. Okay. So once I get this index table built, I can then compare any years. So again, this is an arbitrary choice. You can make this based off of any of the years. It's just you have to know what year you used as your reference. And again, there's no magic to that other than just picking a year and then building your table. All right. So any questions or can I turn the page?
Yeah.
Everyone else good? Now let's talk about something we call consumer price index. So, and forevermore, we will just refer to it as CPI, Consumer Price Index. Now, this is based on an average of prices for a sample of more than 60,000 goods, services, and housing costs. It is computed and reported monthly. So, I mean, there's a lot to it. Incidentally, I mean, if you would go to school and become an economist, you're going to take a lot of math. They are tied hand in hand. It's reported, the government agency that comes up with this is called the U.S. Bureau of Labor Statistics. And these represents an average of prices of sample goods, services, and housing, and out of some 60,000 items. Now, how all that's collected and the index calculations themselves are pretty complex. I mean, beyond the scope of this class. But they are index numbers at the end of the day. Once I have it, and they're going to work just the same as what we have just been looking at. So it's just an index number. Now, currently, right now, the reference value for us, that is what value and what year do I use. It's a little bit more than just 1 year. It actually takes the prices during the period from 1982 to 1984. So the current price index, consumer price index table uses that as its reference value. Now, this is something I wish I was able to just put right up on the screen. The table that I'm referring to in the book is table number 3.4 on page 170. You can find this table. Within the homework, those tables are provided. So you don't need to worry about having to write this down or something like that. It's just, it would be nice if I could just show it real quick up on my share screen. But what I'm going to do is just write out a little portion of the table to give you an idea of what the table looks like here. It's called the Average Annual Consumer Price Index. That's the name of the table. So average annual consumer price index. And then you'll see right here, and this is again where we put reference value. So 1982 to 1984, and we say equals 100. All right, so and then the table itself, you'll have 2 columns, a year and what the CPI is, what is that index number. And so it starts, the table in the book starts in 1977 and the CPI is 60.6 and then 78 and then 65.2, yada, yada, yada. Just doing that. And this particular table goes all the way through 2016. So it's actually got 4 columns of this. And so you'd have more, and then another column, and then finally the table ends 2015 index number was 237. And 2016, the CPI was 240. And again, these are just, so it's going from 1977 clear through 2016. But these numbers right here are index numbers. And so what can I do with them? If I wanted to compare 2015 to 1995, typically we'd say, what was the CPI of then of 1990 or 2015? We got it written right there. It was 237. On the table, the CPI for 1995. And so we just use this as a subscript to say the CPI 2015 compared to the CPI of 95. 2015, it was 237. And 1995, it was 152.4. So if I go 230, I get my calculator, I go 237 divided by 152.4. I'm going to get 1.555. Now, what's that mean? Goods, services, housing, but typical prices in 2015 were 1.555 times higher in 2015 than they were in 1995. Right, so that's what that number tells you. And I could figure that up to compare any 2 years. So if I bought an item that cost me $1,000 in 1995, it's going to cost me $1,555 in 2015. Right. Does that make sense? And so again, you don't have to worry about where these index numbers come from. You just have to be able to use the index numbers. And you don't have to memorize them. They'll be, you'll be given these tables when you work problems. All right. Okay, so let's do another problem. I'm going to go ahead and turn the page, and as we need the index numbers, I'll give them. So you won't, I'm not going to try to draw this whole table. But typical kind of question. So let's say you needed $30,000 for a particular standard of living you were looking for in 2010. So to maintain a certain standard of living. Okay. So what we want to know is how much would you need in, let's say, 2016 to maintain that same standard of living. So what I would need is the CPI for 2010, and I would need the CPI for 2016. And so I'll say CPI 2016. We're going to divide that by our CPI of 2010. And that will tell me how many more times things are going to cost me in 2016 as compared to 2010. So you would pull off the table and just find the index number for 2016. It's 240. And the index number for 2010 is 218.1. And then I would just get my calculator, do the division. I would get 1.1. Carried out a couple places there, but it's 1.1. So typically prices were 1.1 times what they were in 2018. So I could now go 1.1 times 30,000. That's going to give me 33,000. So how much would I need in 2016? I would need to maintain that same standard of living that I needed back in 2010. I would need 33,000. Questions on that?
I think I'm okay.
All right. Well, let's talk about inflation then. So when we talk about rate of inflation, so rate of inflation from 1 year to the next is the relative change. We have heard that before. We're talking about a percentage change. We're comparing by percentage. Is the relative change in the CPI, Consumer Price Index, from 1 year to the next. So in order to calculate rate of inflation, I need to have the CPI table. So I can see what the index number is, the Consumer Price Index is for each year. So let's say I wanted to know the inflation rate. From 1978 to 1979. Now, I was just a little kid back then, but I could remember my parents complaining a whole bunch about inflation. It was out of control back in the mid to late 70s. But since we're talking, it is a relative change, then the way I would calculate it is I would take the CPI in 1979 minus CPI of 1978 and divide that by the CPI of 1978. Now, we've done this kind of calculation numerous times now with percentages. I'm comparing, 79, how much more did it increase? So I need that absolute change and then divide it by my reference value. And so what I would need is I would need my CPI table. And I pull the numbers off. So for 1979, it's 72.6. For 1978, the CPI was 65.2. And I would divide this by 65.2. So inflation from 78 to 79, this comes out 0.113, or that is 11.3%. All right, so now, which is, again, very accurate. It was very high back then. Prices were, general prices were increasing at an incredible rate. Our inflation right now is it's a little dicey. If I would look at inflation rate from 2015, to 2016, I should find that this is quite a bit less. Now, right now, from like 21 to 22, it's a little bit more than this, but so I would want the CPI of 2016 minus the CPI of 2015, and then we'll divide by the CPI of 2015. All right.
So do you always want to put, so I'm just not understanding why you put the CPI of 2015 like underneath of it, and
Okay,
then how you
so-
got like,
All right, good. No, it's a good question.
yeah, because I just don't understand that part, I guess.
So want to reflect back to something we have done previously.
Okay.
We're kind of what I, maybe a good way to put it is we're doing the same thing, we're just calling it something else. Give me a second. So let's say I want to define back at the beginning when we were talking about relative change. We defined relative change, that was percentage, your new value minus your reference value divided by your reference value. So if I'm wanting, and it's a comparison, how much did this new value, how much in percentage did it change from your reference value? And that was the way we computed it. So
Mhm.
when I want to know the inflation rate from 2015 to 2016, my reference value is my starting point, 2015. My new value,
Oh, okay.
does that make sense now?
Yeah, that makes sense now. Yeah.
Okay, so it's this calculation right here. And then this was a renaming of something we did back in chapter 2.
Mhm.
But it's still the same exact calculation. So, now, shoot, I've lost, hold on, lost my whiteboard. There we go. So you would go to your CPI table. CPI of 2016 was 240. CPI of 2015 was 237. And divide by 237. Now this time I'm going to get 0.01266. So if I move my decimal place twice and round to tens place, 1.3%. Prices did not increase that much from 2015 to 2016, as like they did between 78 and 79. We would find this number right now to be higher, from like say 21 to 22 or 20 to 21. Okay, so the thing is, things are kind of relative. That's that's a great word when we talk about relative change. But with the CPI table, I can do things like this. I could just say, well, something cost me this much in 1965. How much would it cost me in 2015 dollars? And I can use my CPI table to do that. That is adjusting prices for inflation. Adjusting prices for inflation. So this is a kind of an important formula. This one you definitely want to write this one down, have in your notes. Adjusting prices for inflation. All right. So if you are given a price so let's write for year Y, let's make it X. And I'm going to denote this with a dollar sign and a subscript X. That's our price. The equivalent price in dollars for year Y. This shorthand dollar sign subscript Y is. All right. Formula looks like this. Price in year Y equals the price in year X times CPI of Y divided by CPI of year X. So remember, X is the one you know. That's the price you know. So if you want to know how much it's going to cost you in year Y, you're going to multiply that price you know by the CPI, Consumer Price Index of year Y, divided by the CPI, Consumer Price Index of year X. So, as an example, here's a dandy. Something dear to my heart. I'm a big, huge baseball fan. My team did not make the postseason again. But one thing, if you can make it to the major league level, I play in a in an adult league, and I have for years and years, but I don't have the talent to play professional baseball. I wish I did. But even if you can make, you're good enough to say play college and then in the minor leagues, very few people can actually make it to the show, to the major leagues. But if you can make it there, you're gonna make bank. That is a fact. So 1987. Average salary. Major League Baseball players. Was $412,000. All right, pretty good. Pretty good. Pretty good work, right? Now, in 2016, the average salary, this is like averaging all the salaries together, called mean. Added them all up, divided by the number of people making these salaries. The average salary was $4,380,000. That's the average salary. Okay. So here's an interesting question. We could certainly compute the rate of inflation from 1987 to 2016. Are these numbers respective of inflation? That is, what I can do is I can come in and figure out, given inflation, what should the salary be in 2016 if you just factored in inflation? That's what we're going to do. We're going to do the same thing right here. So this, again, this takes into account inflation. So since I want to know what price, what should my salary be if I take into account inflation in 2016, then this is what I'm looking for. So I'm looking for the price in 2016, year 2016. Well, that will be the price in the year 1987. Which we know. And then that will be times then the CPI. So always the year you're looking for, the CPI of the year you're looking for. That is CPI of 2016 divided by the CPI of the year you know, which was 1987. All right, so the putting in the numbers, that's going to be the $412,000 off your CPI table. 2016 CPI 2016 was I just wrote 2016 down. CPI of 2016 was 240. Divided by the CPI of 1987, which was 113.6. Well, multiplying these two together, get rounding about $117,000. All right. So what are we saying? We're saying that if we just factored in inflation and inflation only, then the salary in 1987 of 412,000 should be what? 817,000. What is the average salary? 4,380,000. It increased way more than inflation. So again, great work if you can get it. It is not easy. Now you can go ahead and divide. Now, how much more if you divided what the average salary is baseball players is that year, 4 million by what it should be, taking into account inflation only. You're roughly about 5, or it's about 5 times more. 5 times more than the rate of inflation from what it should be, what we call real terms, or adjusting for inflation. And yeah, so I don't begrudge anybody for making the money they can make. So that was not disparaging baseball players. If you can make it, do it. Free agency had a lot to do with that. But again, it's not easy. So very few people can ever rise to that level. So there are other index numbers out there. We have one called Producer Price Index. If you make goods, so the prices that manufacturers pay for goods they purchase rather than the prices consumers pay. And there are other different kinds of indexes. There's a consumer confidence index, how much designed to measure consumer attitudes, so on and so forth. But index numbers, again, always, whatever index you're looking at, the math of it always works the same. So, so the homework has 15 problems. And basically, I've gone through examples of kinds of problems that you will see. And so I'm assigning 3D. There we go. Today is the 5th, so I'm going to put Thursday as the due date. It is assigned. I would expect there might be a question or two, and we will go over whatever questions you have on Thursday. On Thursday, I do intend to move into Chapter 4, 4A. There will be a Chapter 3 quiz. I will also assign, and I'm going to do a little bit with 120E. So, yeah, but that's where we're at. So, go ahead.